Hi, now that you have tried 17, you can watch this video to get a quick check to see how you did. So sorting these out, which one are independent and which one are dependent. Flipping a coin 2 times. It doesn't matter what you get on the first one. It doesn't change your second. So it would be an independent event. One does not affect the other. Spinning a 5-section multicolor spinner 4 times. Again, those are going to be independent. One spin doesn't change the other. Selecting a number tile, then selecting another without replacement. So think about like playing Scrabble. You take a number out and then you draw another one, but you've kept that first one. And so depending on what you get the first draw affects what you would get the second one. So that one is a dependent. Choosing one player to be on your team and then selecting another. Well, again, once you have chosen that player to be on your team, they're on your team, which means that you have fewer people to choose from. So who you choose affects who is left and how many are left. Rolling a 6-sided dice 3 times in a row. One does not affect the other, so it should be independent. Selecting a letter tile, then selecting another one without replacement. That's the exact same thing. So there's no reason to have it on there twice, right? Selecting a letter tile, then selecting another one without replacement. Yeah, same thing. Delete it. Sorry about that. Selecting a random card and then selecting another one without replacing. So again, if you put one ace in your hand, that means there's one less card for you to maybe get another ace. So that would be dependent events. So hopefully you got those correct. And then we can look down here and see how you did during this practice. If you flip a coin twice, what's the probability of flipping heads both times? So the probability of getting heads the first time is 1/2. In fact, there's 2 things happening here. And so I like to know that there's going to be 2 things that I have to multiply. Here, there's 3 things happening, and so I know I need 3 different things going on here. Here, so you roll a 6-sided dice twice. That means there are 2 things happening. And this one, I kind of wrote it out. But when you do your extra multiplication, that means you'll have 2. And then here, so you roll a 6-sided dice 3 times. So you're going to see 1, 2, 3 things multiplied. So 1/2, because that's the probability of getting heads, times 1/2. Remember, you do your numerator first, so 1 times 1 is 1, 2 times 2 is 4. If you're going to flip a coin 3 times and getting heads 3 times, the probability of getting heads the first time is 1/2, second time's 1/2, the third time's 1/2, because it doesn't matter what happened beforehand, it doesn't change it. These are independent events. 1 times 1 times 1 is 1, 2 times 2 is 4, times 2 is 8. 6-sided dice twice. What's the probability of rolling an even number and then an odd number? So the probability of getting an even is a 1/2, because it would be a 2, a 4, or a 6. So it'd be 3 out of the 6 total, which simplifies to be 1/2. Same thing with odd. 1, 3, 5. 3 choices. 3 out of 6 is 1/2. So 1 times 1 is 1, 2 times 2 is 4. Now down here, they give you a little more. They have 1/2, where they want you to roll an even number, a 6, and a 1. So the first one, if you think about rolling an even number, again, 3 give you what you want, 2, 4, 6. 3 out of 6 total is 1/2. How many on a dice is a 6? So that's 1 out of 6 total. And how many are a 1? 1 out of 6 total. And so then your math problem becomes 1/2 times 1/6 times 1/6. 1 times 1 times 1 is 1. 2 times 6 is 12. 12 times 6 is 72. So hopefully you got page 17 correct. Now let's look back at page 18. There are cards labeled 1, 2, 3, 4, 5, 6, and you randomly select a card without replacement, and then you select a second card. Okay, so like if I draw, like on this first one, the probability of drawing a 1, that means it's no longer there, and so then I only have the 5 cards to choose from. So how this works is you would think about the probability of drawing the 1. There would be 1 out of the 6 total. And then the probability of then drawing a 2, remember the 1 is gone. It is no longer here. And so the probability of drawing a 2 would be 1 out of 1, 2, 3, 4, 5. So 1 out of 5. Oops, now I need to go back here, I guess, before I can. So 1 times 1 is 1, and then 6 times 5 is 30. So it would be 1 out of 30. Now, let me erase this. New problem, start all over again. It says, what's the probability of drawing a 3? Well, if you drew a 3, that means there's 1 3 out of the 6 total. And then a 5, well, the 3 is gone. And so the probability of getting a 5 again would be 1 out of 5 because the 3 is no longer there. And again, 1 times 1 is 1, 5 times 6 is 30. But what about this one? Because it says even. So if it's even, then so the probability of it being even would be a 2, a 4, and a 6. And so again, that would be 3 out of 6, which simplifies to be 1/2. And then you always assume you got what you want. So you didn't get all of the even, you only drew 1 card. So mark out one of the evens, okay? And now you'll see that there are 5 cards left, and how many of them are odd? 1, 2, 3. And so this time you would say there are 3 out of 5 that are odd. So 1, looking at your numerators, 1 times 3 is 3, 2 times 5 is 10. And so the probability of getting an even and then an odd would be 3 out of 10. So we're going to do one more. What would happen if you wanted to get a 1 and then a 6? Well, it doesn't matter which cards you're talking about. You're talking about one number and then the other number. And so it's just like what we've done on the first 2 problems. Probability of drawing a 1 is 1 out of 6. It's gone. Now there's only 5 cards left. So it'd be 1 out of 5. So you would get 1 out of 30. Now, what I would like for you to do before you watch the next video is I want you to try the bottom set of the questions, practice those, and then tune into the next video to get the answers and to see page 19. Thanks for listening. See you in the next video.